In this lesson, we are going to learn how to determine the number of subatomic particles that make up an atom. Now, when we look at an atom, we have this form of notation right here. So let's define what all the numbers represent. First of all, the most important one is the element. It could be any elements in terms of the element symbols. And then we have the bottom number that represents the number of proton, or the atomic number. So that is your number of proton, which is positive charge. And each number of proton represents a specific element. Then on top we have the mass number, which is equal to the number of proton plus the neutron. So we can use that information to solve for the number of neutron. And if this atom is an ions, we would have the charge of that specific atoms or ions. And the charge of an ions is equal to the positive proton and the negative electron combined together or adding together. In this case, we are going to look at specifically the charges and how is that related to the number of proton and electron. If we talk about the charges, we are referring to the net charge of an atom. What does that mean, net? Net is when you combine the positive and the negative and you combine together. The positive and the negative cancel each other out. You have your net. In order for the net charge to be zero, which is when an atom is neutral, the only way, if you do this mathematically, is that the proton must be equal to the negative electron, because the positive has to cancel out with the negative, give us the positive proton equal to the negative electron. Now, for any atoms, this number of proton will always stay the same because all the way inside the nucleus of an atom, it doesn't get removed easily. But for the electron, on the other hand, it can be gained or lost. That is, an atom can gain electron, and gain those negative electron will have the overall effect. If you're gaining negative, what happens to the net charge? Of course, you become more negative. So the net charge becomes negative. And in mathematical terms, basically, the number of electrons are now being added. Well, what are you adding in originally? Originally, you would have the number of proton equal to the number of electron. So when you have a negative charge, that tells you you are adding the electron to the number of proton. Where if you lose electron, when you lose the electron, which are negative, you become more positive, okay? In that case, you are going to subtract from the number of proton, because the number of proton is actually equal to the number of electron when the net charge is equal to 0. In this case, what I have here is oxygen. So first of all, this is our net charge, okay? And this is our number of proton right there. So what we have here is that negative indicate that it has gained 2 electrons. That's give us the negative charge. So since it's gaining 2 electrons, we are going to add that 2 electron to the number of proton. So in this case, our number of proton is 8. So our total number of electrons is equal to 2 plus 8, and that gives us 10 electrons in this atom with a net charge of -2. And that's all we have to do to determine the number of electrons. And for the number of neutrons, of course, we can take the mass number minus the number of proton, in this case 16 minus 8, and that gives us 8 neutrons. And that's all we have to do. Let's do another problem where we have the opposite scenario. Let's try another problem where we have the opposite scenarios. In this case, we have a positive charge of positive 3. So that positive tells you that it has lost 3 electrons. That's why it becomes positive. So we are going to subtract from the positive proton, which is this one right here. That's the number of proton. So in this case, we subtract from the proton, which is 5 minus 3, give us 2 electrons in this atom, or specifically ions. And for the number of neutrons, you take the mass number minus the number of proton, give us 11 minus 5, give us 6 neutrons. Let's try another example again with a negative charge. In this case, I have nitrogen, which the negative indicates that it has gained 3 negative electrons. That's why it's become a negative charge, okay? So in this case, when it gains, so we're going to add to the number of proton. So the number of proton is 7. 7 plus 3 give us 10 electrons. And for the number of neutrons, you take the mass number minus the number of proton and give us 15 minus 7, give us 8 neutrons. And voila. And of course, this is the number of proton. Let's try another problem with a positive charge. In this case, we have calcium ions, or an atom of calcium with a positive 2. So this one tells you that it has lost 2 electrons. You lost a negative, that's why you become positive. So because it lost an electron, we have to subtract from the original number of protons. So 20 minus 2 gives us 18 electrons in this atom with a net charge of 2 plus. And for the number of neutrons, we would have the mass number minus 20, which is the number of protons, give us 20 neutrons. And that's all we have to do.